Hello and welcome to our today's lesson. In today's lesson, I'm going to explain you about the construction of DC machine. When you say DC machine, it can be a generator or it can be a motor. And let's start from the construction of DC machine. In terms of constructional perspectives, DC generator can be a DC motor or DC motor can be a DC generator. So there is no any constructional difference between the two. So if you have a generator, you can use it as a motor, or if you have a motor, you can use it as a generator. There is no any constructional difference between the two. So let us see the detail of the construction of the DC machine. When you see the constructional perspective, we have about six principal components. The first one is the stator core, or it's most commonly known as field core, and the stator winding, which is also called field winding. And this both the stator core and the stator winding are the stationary part, and inside this we have a rotating part called rotor, or most commonly called armature. This armature also consists of both the armature core and the armature winding. Unlike the AC machine, the DC machine has got two additional components in addition to the field winding and the field core and the armature winding and armature core. These two components are the commutator and the brush. The function of both the commutator and the brush is to convert the AC signal into DC signal. Internally, all DC machines are AC machines. So whether it's generator or a motor, in case of generator, DC machine generates AC signal, and it is the AC generated signal or voltage is converted into DC through the commutator and the brush. If it is a motor, you give AC supply, DC supply through this brush, and this commutator will convert it into AC, and that pulsating or alternating current will produce the rotor to make the rotor to rotate. So internally, any DC machine is AC machine, but it will be converted. The AC signal is converted to DC through the commutator and the brush. So usually this is known as mechanical rectifier. So you can see here, in terms of construction, this is a field part, the field core, and this is armature part and the rotating part. And these are the brushes, and this is a commutator. As you can see, the commutator is directly connected with the armature. So this is the constructional perspective of DC machine. Now let us see one by one. The first one, the stator or the field part. So the main purpose of the field is to produce a magnetic field. As you can see here, this is a field part or the stationary part, and this is a pole. These are poles, and these poles are wound by a copper coil. So you know that from electromagnetic induction principle, whenever we wound a conductor, a metal, especially magnetic materials, whenever you wound a magnetic material with the copper and supply DC to this conductor, this magnetic material will become a magnet, or it will become a magnet, or it will produce a magnetic field. So the main objective of this stator or field winding and field pole are to produce the magnetic field. So in addition to the main poles, now as you can see here, especially when the DC machine is a bigger one, it usually consists of additional small poles with the winding. These are known as interpole, and the winding is known as compensating winding. The purpose of this interpole and compensating winding is to improve the commutation process. So it is usually at high load machine or high power rating machine, they are used to support the commutation process. But for a small machine, we might not, we can ignore it. or we might not need it. So when you see the detail of the construction, any DC machine, specifically the field part, consists of the yoke. The yoke is made up of cast steel, and it is just for the protection of the machine. And the field poles, these are the field poles. And interpoles, as I mentioned, this is optional. Field winding, these are the field winding. And compensating winding, the compensating winding is the winding that are wound on the interpoles. Usually, the adjacent poles are opposite in polarity. That means when we wound, we have to care of that. This, if this is a north pole, and the adjacent pole should have to be south pole, and the next will be north pole. And there is no way that the poles say north north and south south, something like it's not working. Usually, poles are arranged in such a way that the nearby, the adjacent pole should have to be opposite to each other. And the air gap between the stator and the rotor is usually assumed to be 0.5 millimeter to 1.5 millimeter. Usually, it is in any machine, it is convenient if the air gap is as small as mechanically possible. It should have to be small. I mean, it is better for a better performance. The air gap should have to be small, and the minimum small, the smallest one is, I think, 0.5 millimeter. So these are what we have mentioned about the interpole and the compensating winding. Then you can see here also, this is a main winding, the main pole, and this is a main winding. And these are the interpole and the compensating winding. So these are the additional about the interpole and compensating windings. And the same is true for the interpoles. The adjacent interpoles, if this is north pole and the next will be south pole and north pole and something like that. The same as with the main pole. When it comes to the armature, and the armature is usually made up of the cylindrical shape, and you know that any machine, whether it's transformer, generator, or a motor, should have to be laminated for eddy current reduction. So the same is true here, and the rotor is always made up of laminated steel. So this is a laminated steel, and finally varnished. So with the thickness of 0.4 millimeter to 0.6 millimeter, and the ideal is 0.5 millimeter. So this is a rotor part. And unlike the AC machine, in this DC machine, we have also a winding in the rotor or in the armature. So we need to have slots in the armature as well. So these are the slots in which the winding are placed. And usually this rotor is attached with the commutator, and the in winding of the armature is directly connected to the commutator, so through a riser. Therefore, here you can see the commutator. These are the risers that are connected to the rotor part, I mean the armature part. So this is a way that the internally induced voltage will taken out to the commutator through this one. And when you see the commutator, always this commutator is made up of the copper, and these segments are separated by an insulator. Most commonly, we use mica to insulate the adjacent, the commutator's segments. So this is a commutator which is directly connected with the armature. So when you see the detail of the commutator, it is called the mechanical rectifier, as I mentioned, and it is insulated by mica, and the connection of the armature conductor to the commutator is made with the help of riser. This is riser, right? These are the risers. These are the risers. So through this way, we can connect the armature and the commutator. And always we have to be careful when we especially connect the, when we solder the commutator with the with the rotor, we have to take care of that, because sometimes when you solder, if these two terminals are connected to each other, so there is a possibility of making a short circuit. So we have to carefully solder that one, and that misaccuracy will maybe cause the bouncing of the brush and may cause the spark. And let's come to the brush. And usually when you see the brush and the commutator is directly attached connected with the rotor or the armature, whereas the brush is directly connected with the yoke, the stationary part. So usually the commutator will rotate, but the brush are stand still. And the number of brush used in a machine depends on the number of pole of the machine. Usually the number of brush is exactly equals with the number of poles. So if the machine is a 4-pole machine, and we need to have 4 brushes. And finally, as you can see here, inside there is a conductor. Inside this ring there is a conductor. Inside this spring there is a conductor. This conductor will be taken out to the terminal box, and we can either supply or we can take it out the induced voltage through this terminal box, and that is found on the yoke of the machine. And usually, since there is a high friction in between the brush and the commutator, so always there is a tendency of that this will be sometimes damaged. So we need to always replace these brushes, and that's why the DC machines need much attention and much troubleshooting or maintenance, frequent maintenance than that of the AC machine. So these are the brushes. This is the one has to be replaced, and you can online buy, or you can directly get these brushes from the shops. So the purpose of brush is to ensure the electrical connection between the commutator, because it is difficult, if it is difficult to collect the induced voltage from the commutator or the rotating part. So we need the brush to collect the induced voltage. And when you see the construction of the brush, it is usually made up of carbon or electrographite or copper graphites. So brushes are usually has to be adjusted, because when high pressure between the brush and the commutator is there, so that is not also good. And if the pressure between the brush and commutator is also weak, it's not also good. So we have to always adjust the brush, the force between the brush and the commutator. So it should have to be normal always, unless and otherwise it will create a spark, and it will maybe damage even the commutator. So this is a complete part of the constructional part of the DC machine. In the next lesson, we will see the detail of the generator, the DC generator and the DC motor with the separate video. And I thank you very much for your attention. See you. Bye-bye.